Welcome back. This is week 4 of Intermediate GIS Applications for Real Estate. This is Yash Yedavali, and this week we'll be talking about Network Analyst. So essentially we'll be learning about what Network Analyst is and what it can do for you, and how it can be used in a more, sort of like a real estate point of view. So when you talk about Network Analyst, it is an extension of ArcGIS. Obviously, this is why we are learning it. Using this, you can answer questions like what is the quickest way to get from point A to point B, and what market areas does a business cover, or which ambulances or patrol cars can respond fastest to an event, or we are talking about it can also answer questions like how can a fleet of delivery service vehicles improve customer service and minimize transportation costs. Where can a business open a store to maximize market share? And if a company has to downsize, which store should it close to maintain overall demand? Sort of very location allocation or vehicle routing problems. These are the typical problems that network analysts help resolve. So when you talk about network analyst, you talk about different solvers. So the most important of these are actually service areas and location allocation and origin and destination cost matrix. Those are the three most important for us in terms of like real estate point of view. So we'll learn about this stuff, and we'll actually work with a lot of data and see how these analyses are performed in real time. So what is a network? It is nothing but a street network. If you talk about a street network, you talk about interconnected elements such as lines and junctions and possible routes from location to location. So it's a very complicated network. Even though you're talking about street, it's extremely complicated. There are different extensions even within ArcGIS to manage geometric networks such as pipelines and sewer systems, all that. It's called a geometric network analyst. What we are talking about in terms of network analyst here is only street network analyst. So how do you work with network analyst? You need to have the extension which is provided to you, and then you need to work with network datasets which can be created using the same network analyst extension. Some of these you don't really work on creating network datasets so much as you will use these network datasets that were created for you. So you're sort of like the end user of these datasets, and then you use ArcMap to perform your analysis and manage your data, and you can there are several ways you can do this. So network analyst controls, we'll see how this is done. We'll open an ArcMap, we'll enable the extension, we'll add a network analyst toolbar and a window, and we'll talk about what the window has and different options that are associated with that. So again, remember that the network dataset is unlike any other dataset you have worked with so far in ArcGIS. This is it's called a network layer. When you create a new solver, when you start a new network, when you're trying to solve a particular problem, you need to create that use that solver. When you click on that, it automatically comes up with different solvers. We'll talk about that. And these are, remember, these come in a network layer package, and it holds the reference data set in network data. Specialized layers, again, it's a composite layer. When you're trying to solve an issue of shortest route, so you'll have stops loaded into one layer, you have point barriers in other layer, and then you have your results, which will be the route that will be created in another layer. So these are sort of like composite layers configured for a specific solver, and these vary from solver to solver. So we'll see what those different solvers are as we go along. So let's talk about street networks with network datasets. So where do you get this street data? Usually some of this data is available for you via data and maps DVD when you actually buy a software like ArcGIS. It comes with like a basic data package, and it should have a bunch of street data within it, which is mostly free. And then there is Tiger. You can always go to the census website to download the street network files and create your own network data sets. And then there is community data from OpenStreetMap, and or if you are a civil engineer or you work for the Department of Transportation, you have your own data. And then there are vendors like Navtech and TeleAtlas, who actually provide some of this street network data, which you can buy for a hefty price. Again, it really depends on the level of sophistication you are looking for and accuracy you are looking for. Euclidean and network path. Again, let's talk about what does a network data set, how does this network analyst work. So instead of actually, if you have a point A to point B and you need to get from point A to point B using a network, you have to travel around this sort of like the river and actually take the actual roads to actually get to point B, as opposed to a crow distance, which is also called as Euclidean distance, which is essentially a straight line distance from point A to point B. So what this network distance does is it actually gives you the real cost involved, or time cost in this case would be time and distance involved from traveling from point A to point B. So there is a major difference. As you can see in this case, this is almost 10 times more in terms of just distance and time actually to get from point A to point B. So some other terminology you need to be aware of is street connectivity. How are streets connected? If you look from the above, like from an aerial, like a top view map, you won't really see what's going on underneath. All the streets look sort of interconnected, but if you actually examine it more closely, in reality those streets are not all interconnected. So essentially you need to model that, because you can't jump from one flyover overpass to the next so easily. Sometimes you have to travel miles and miles to actually get from point A to point B, even though they're right next to each other. So that's what a network analyst or network dataset models. It actually evaluates this connectivity and takes into account cost as attributes while creating your network dataset. So cost attributes, when we talk about cost, essentially what cost means is sometimes it's also called impedance, whatever that is. Whenever an agent traverses, so a cost of traveling from A to B is 1 mile or 1.2 minutes in driving time. So whenever we talk about network analysis, the cost is always distance or time. So that's what a cost attribute. This is actually modeled into the network because we already have distances, and each of the streets has a speed limit, and based on those speed limits and the distance, you will be able to calculate time. So essentially what you're looking at is a simple Google map sort of a thing, where you actually find your shortest path to point A, from point A to point B. So this cost attributes are calculated based on turn delays. So what happens when you have to turn from a smaller road to a main road? Now, it takes longer. It takes about 15 seconds to actually make the turn because of the traffic, because of the angles and all that. So you actually let the system handle these cost attributes by modeling them while you are creating the network. So when you add a cost to every turn, like 15 seconds is the cost here. So you are essentially reducing the number of features you need to digitize, and so on and so forth. Essentially, it will give you a much more advanced and much more sophisticated and accurate cost estimates when you are actually performing analysis using this network dataset. So this is mostly for creating the datasets. You don't really need to worry about like creating datasets so much. When you well, most of this data is already created for you. So some of the cost attributes could be historical traffic. So what you can do is you can even include historical traffic data to actually calculate best routes because of the given traffic delays and so on, and get a more accurate arrival times or cost of travel. And then you can use restrictions like one ways and no motor vehicles and no left turns and no U-turns to actually get a better description of better estimate of cost associated. And then you always the more advanced network can be derived from modeling attributes like height and weight and width limits, so that you get the best possible estimate. So just imagine this: what if a truck driver who is new to the city doesn't actually know which route to take, and his GPS actually has a pretty bad network which does not account for weight and width limits? This is what happens, because he won't be able to get under that overpass. So it's extremely critical to actually model for all this stuff, and that's why it's more complicated to actually create this network dataset. It's a lot more easier to actually use the network dataset because it's already been created the right way. It takes a lot of work to actually create these network datasets. So a U-turn policy. Sometimes the shortest routes include a U-turn, but if you want to restrict it, you can go for it. And then there is something called restriction barriers. Like, what if there was a natural disaster? You really don't want to go through that. So when you actually look at Google Maps, they have traffic information. They say, okay, there is an accident somewhere. Even some of the latest GPS systems that you have in your cars and on your phones will actually sort of like warn you, okay, there is a flood, you can't go through that area. There is a road closure, there is a parade, and these are live traffic updates based on which you can model your routes and solvers. So again, we are talking about cost barriers or scaled barriers, where you say, okay, there is a single lane closure. Essentially, all this can be used to model your network, or these can be live updates. Most of these are live updates. The reason I'm showing you all this is that you need to understand how complicated this network dataset can get, because you keep adding these barriers and cost attributes and different even something as simple as a curb approach. So can you stop right next to a curb, and can the people actually get off a curb? Is there a sidewalk? So this kind of stuff actually helps can be modeled and can be actually used to create a better analysis or better cost estimation of what it's going to take to actually run this analysis using that particular network dataset. So if all these are not available, your analysis would be less accurate and less it will give you a wrong estimation of cost associated with So let's talk about solvers. When you talk about network analyst, the main thing that you'll be using as a real estate analyst or a research analyst or a property manager, whatever it is, you'll be using the solver. You won't be worried too much about creating these data sets, but use these data sets to actually solve a problem you might have. So some of the solvers is route solver. The best route sort of like optimizes the travel cost through a series of stops. So essentially you can find the best sequence, where are the best stops, and what are you can get like directions and start time and so on and so forth, so that you can get the best customized route possible for your travel. And then there is a cost closest facility solver, which actually finds the nearest facilities from each incident essentially. So if you are a 911 operator in this case, you can figure out who is the closest, who can get there fastest, which patrol car, and they can essentially allocate that case to them. So the variations in this would be cutoff value and number of facilities to find, because if you say instead of actually find the 3 closest cars, if you say find me the 50 closest cars, that wouldn't be of much value. So you need to have a cutoff value and then direction of travel. So again, there are a lot of attributes that could go into it. So we'll actually work on the service area solver, which actually finds the areas you can reach from one or more locations. So based on this, you can let's assume these are store locations, 5 store locations that you are managing, and you need to figure out what is the market area for this store location. Essentially, most of the stores, they have a drive time. If it's a grocery store, you say okay, 3-minute drive time or 5-minute drive time. You have a catchment area or a service area. In order to actually see or find new possible locations for your stores, you need to sort of like overlay these store locations all at once. So that kind of gives you a service area and what is covered by your stores and what isn't. So stuff like this could be extremely useful in performing your analysis. And also there is a location allocation solver, which actually determines the best location for a facility based on demand conditions. What that means is it actually minimizes cost and maximizes coverage, and it actually, the main thing it does is minimize facilities. So if you have too many stores, it's going to tell you that okay, you don't need so many stores to minimize or maximize. Sometimes it can help there are different types of analysis you can do. If you want to maximize attendance, you can run you can put a priority on maximizing attendance or minimizing facilities or maximizing market share, and if you have a target market share, it's going to help you figure that out as well. We'll look at this a little more closely when you are actually working on the solver. And then there is the vehicle routing problem solver, where if you are a into distribution or delivery services, you can figure out if you have a fleet of vehicles, you can figure out what vehicles should take which route and what is the best way to actually deliver all these packages within time by actually breaking the workflows. And so you can even model like driver specialities and capabilities and work breakdowns and so on and so forth. So pretty extensive stuff if you are into logistics at all, delivery service sort of a thing. So again, we won't really work on this too much because it's slightly outside our scope, but it's good to know what the network analyst extension can offer, And then there is the origin destination matrix solver, which actually creates a matrix of travel costs from between different points, origins and destinations, which in this case seems to be origins and then warehouses. So it's sort of like, so this OD matrix can be used as an input into logistic routing models that can use OD matrices to allocate goods and services. So again, this is something that you need to be familiar with, and then takes essentially OD matrix, how it is done. It takes like set of 2 inputs, one is origins and one is destinations, and then produces a table of cost of distances. So when using OD, it has to be a specific case. So geometry is not important for you. Essentially, whatever is the closest facility, if you are trying to actually find the closest facility, then you have to use the closest facility router. But if you are using origin destination matrix, just remember that output geometry does not matter because it's gonna calculate it based on the Euclidean distances most of the time. So again, to sum up, benefits, there are a lot of benefits. It can use an accurate model of transportation network, to actually perform this analysis, and also you can create these accurate transportation networks quickly and easily, and you can really solve complex problems. And essentially, this is a extension that will help you solve, save money. This is a money saving extension. Shorter routes means less gas, obviously, less maintenance, less driver overtime, and more customers are served, and so on. And also it'll help you like optimize your business model by locating facilities at the right points and remove redundant facilities. So again, it is used across RGS in various various domains. We'll look at what the network analyst workflow is like in real time. There are some slides here to actually help you through it. If you want to look at them, that's fine, but I prefer actually working through the software and learning more about it. So the presentation is within is in the Blackboard, so just go there to actually read through it. Maybe it'll be very useful to do that. And then please be aware that let's look at Blackboard once, because in Blackboard under lectures and resources, you have a PDF document, the network analyst tutorial PDF. Just download that, and we'll be working on exercise 5 and exercise 9, which is actually creating service areas and working on location allocation. So those are the two most important things. I might actually show you a simple closest facility or closest route analysis as well. And then you'll be working through exercises 5, 6, 5, 7, 5, 8, 5, 9 of book 2. So make sure you work through those exercises and finish them and submit the assignments at the end of each exercise. Okay, let's go to the walkthrough.